Our sweat and heart rate variability tracking device is targeted toward people who experience high stress levels. Stress can be very detrimental to people's livelihoods. It's associated with cardiovascular and autoimmune disease, diabetes, cancer, and mental health disorders, including depression and anxiety. Our device aims to address this issue by assessing heart rate variability and sweat levels to alert the user when they become stressed so they can take interventions to reduce their stress back to a healthy level.
Our device consists of three main components: sensors, processing, and LED alerts. A pulse sensor and galvanic skin response sensor we use to collect information on photoplethysmography and electrodermal activity. Data from these sensors is sent as an analog signal into the Mario, where it is processed in a virtual instrument, which allows the acquisition of analog inputs, real-time analysis, and display of stress levels.
The PPG software monitors heart rate with the dynamic threshold setting mechanism for heartbeat detection. We record the number of beats in 10-second intervals and extrapolate this to beats per minute. The BPM from multiple 10-second intervals is then stored in an array, and the standard deviation is calculated from the 6 most recent array values. Stress is indicated by a low heart rate variability. Therefore, if the standard deviation falls below a certain threshold, a Boolean value is produced indicating stress. The EDA software takes a moving mean from data, forming a baseline measurement. Further signals are then compared to this baseline, with values falling below 90% of the baseline indicating increased sweat and quantifying a stress value from 1 to 3.
The device is secured on the user's arm by an armband with connecting jumper wires organized on a circuit board and power supplied by a 9-volt battery, with design aimed at enhancing user comfort.
To test our device, it was worn on the non-dominant hand. Stress was simulated through physiological impact on the body via physical exercise. The subject was recorded at rest, moving 1 limb, moving 2 limbs, and moving 3 limbs, simulating different levels of intensity of stress. Exercise increases heart rate, reducing the period of time in which variability can exist. Further, EDA signals are increased through physical exercise as sweat production increases due to increased emotional arousal. Combining the two quantifies the stress experienced.
The PPG determination triggers LED 0 on the Mario, representing a yes-no assessment of stress. EDA data indicates a stress level, turning on LEDs 1, 2, and 3, with values below 90% of baseline, indicating level 1, below 80% level 2, and below 70% level 3 of stress.
This device represents a solid foundation upon which the Tensible team can build to detect and provide a basis from which to quantify physiological stress for downstream projects. There's the capacity for Bluetooth connectivity, allowing the user full mobility while wearing the device. There's also the capacity for connection to a TENS machine, which will be activated to treat the chronic stress detected by our device. Our team is excited for the potential of the device in a clinical setting and are hopeful that some of the burden experienced by chronic pain sufferers can be eased.